Welcome. We're going to talk about Stephen Hawking today and his theories about gravity, how it's moving the earliest particles, mass, gas into filaments because of imperfections in the distribution of them. It's kind of uniform, but there's some slight statistical displacements which creates a dynamic and then starts moving things. And we're going to show you the clip now. It's a brilliant clip, and yeah, we're just gonna watch now.
Although the calculations were hard, demonstrating what we discovered is easy. First, I need a nice flat floor, like this one, for example. This is the dining room in my college. I'm going to fill the place with lots and lots of ball bearings. These balls represent the matter of the early universe, a thin gas spread out evenly across the vast cosmos.
So here they want to show the beginning when it's kind of fully locked in a sort of a grid with equal distances, which makes everything static and stable, but then something happens.
Here's where luck comes in. If they're all the same distance apart, gravity pulls each ball the same amount in all directions. They stay perfectly aligned and precisely nothing happens. Fortunately, one of the basic rules of the universe is that nothing's perfect. Perfection simply doesn't exist. The early universe had a tiny unevenness that can be simulated by removing just 5 ball bearings.
And this is the basic point they're trying to make here, and then how very quickly you will get clumps into structures, which is the filament that we see today at the whole universe scale with the galaxies.
It may not look like much has changed, but to gravity, those missing balls create a giant opportunity. Gravity now pulls more strongly on one side of some of the bearings. The tiny irregularities in the sea of ball bearings have given gravity something to sink its teeth into. And this is exactly what happened back where we left the young universe. Parts of the sea of early gas were ever so slightly thinner than others.
So what they're showing here is the filaments. This is the large scale of the whole universe, the cosmos. And each light point here is a galaxy. It's not a star. So, but they have this, it looks a little bit like nerve threads as well. But these are then seen here to be remnants from these tiny structures when the universe or cosmos is very tiny. And then when it's stretched out to this enormous size, you still see the same basic patterns in it.
Less dense areas were like the gaps between the ball bearings.
So I'm going to stop there. So just we wanted to make this this point and show you how this is how the gravity is a force that is setting things into motion, and also to point out again that we're focusing now in the beginning on this channel to the especially light and time and gravity, and just cover the basics and then see if there are any big open questions here, or which ones, and then try to develop some kind of thought experiments to just see if we can find some new perspectives on these things. So, but it feels like this is one of the crucial ones, along with the black holes from Stephen Hawking, but also this stretching out, and then also it ties into Roger Penrose on the previous clip. So that's all we wanted to show for this clip, and hope some of it was interesting. Thanks for watching, and have a great day.